We are going to start with activity number 4. It looks like this sheet in your packet. The main question on this one says, what effect does the size of a capacitor have on the amount of charge and energy stored in the capacitor? I have two capacitors here. There's this regular size one, and then I'm going to call this one Big Blue. Big Blue on your sheet is going to be called silver. I did not change the name on there, but I don't have a silver colored one. I just have two different sizes that are blue. So we'll call the silver one the Big Blue. So what I'm going to do is I'm going to ask you, how will the bulbs light, and make a prediction during the time when I charge through the small capacitor compared to Big Blue capacitor. How will the times compare? Will the bulbs light for a greater time, less time, or equal time? And then the second part has to do with how will the handle of the Genicon, so when I discharge through these, how will the Genicon handle turn? Okay, so you're supposed to, will it be greater, less than, or equal to, comparing the two capacitors. And then over here we're going to do this, and we're going to do two different trials, and then for the small capacitor and then for the Big Blue one. Now, as we do this, I'm going to do the charging part here first and then the discharging here. So I'm going to do charging, then I'm going to discharge, charge, then discharge. So we'll start with the small capacitor. I'm hoping this is going to work. So I have this set up, and I'm going to charge up this capacitor. So to begin with, I'm going to make sure that this capacitor is not charged. And so we want to just look at how long do the bulbs light up. So you should be able to see these two bulbs. There's this one and this one. How long do they light up during this time? So I'm going to connect. Okay. Now, I'm going to discharge through the Genicon. So what I have to do is, I'm going to look at this. I want to know how this handle is going to turn once I connect. I'm going to clamp this on because that gained charge. And just watch, how much does this handle turn? Looks like it did a half a turn. Okay? So when I discharged, so that would be going down here, bulb lighting during, it looks like it was a half a turn here. For this one right here. Here it looks like, I would say they lit for like 1 second. So I'm going to do another trial. So watch the bulb lighting again. I'm going to start with this, and when I make this connection we should see those bulbs light. Less than a second. That didn't take very long. And then I'm going to look at this again and we'll look to see how much the handle turns, because there's energy stored in here and that's making this handle turn. Hold it like this. Wow, that didn't turn very much at all. Okay, I didn't get a good charge on there. I'm going to try that again. I'm going to charge that thing up again. First I'm going to reset this. I'm going to charge this. Why is that not lighting? Let's go ahead and do this large capacitor. For some reason that one is not wanting to function as well today. Okay, so now I'm going to charge this one up. So I'm going to reset it first to make sure that it doesn't have any stray charges on it. This is the large one. Watch how the bulbs light on this one. Oh, they lit for a longer time. I'd say like 2 or 3 seconds. Now I'm going to discharge with this Genicon. So I'm going to hook one here. We're going to watch this handle, how much this moves. So we're going to start right here. It's going to be my starting. Here we go. Oh, that went about 3/4 of a turn. Okay. So I'm going to reset this again. So this is the large one. We're going to charge it up again. So watch how long the bulbs light. Make sure all my connections are good. See the bulbs? I would say about 2 or 3 seconds. And then I'm going to discharge through the Genicon again. Connect one. And watch this. Whoops. My hand was in the way. I got to redo that again. So, reset this. Charge it up. Watch the bulbs light. I'd say it's about 2 seconds. Now do the Genicon. Connect one here. Connect one here. Looks like it's about 3/4. Oh, there it goes. Looks like 2 turns. Okay, so we had like 3/4 of a turn and 2 turns on the large one. So those were down here. So what is that telling us? Isn't that telling us that this capacitor is storing more energy compared to this capacitor? That would be the difference between the two. Why would this one store more energy than this one? Well, if you look at the size, doesn't this one have more material inside on it to store energy? So it's going to store that charge. So our conclusion. A larger capacitor stores more charge. And the evidence is the bulbs lit for a longer time, and the Genicon handle had more turns. So in other words, a larger capacitor, and so that was this one, big blue, is going to store more charge, therefore it has more energy in there. So that charge that it gets when it's charging is equal to the charge that it has when it discharges. I was also going to show you, this is a computer motherboard. On this computer motherboard, these capacitors are very large in size because we're working with them and it's just easier to work with a larger size thing. But if you look on this motherboard, if I bring it up closer, there are multiple capacitors. There's some right here, these little here, there's one here, here, and here. These are all capacitors. There's several right here that are all different capacitors in here, and they are used to store charge. So like when your computer needs a little extra boost of charge, if it's running graphics or whatever, this is where it pulls those charges from. Here's some more. Okay, so that's just showing you capacitors are used in multiple things to store charge to be used at a later time.